Hello everyone. So this is session 3 of Java 2 and we're starting with collections API. So collections API we all know is what application programming interface, right? So collections API, it's in Java collection API, collections are just like collections are used for storing objects, for storing groups of objects. You get collections are used for storing groups of objects. So the collections API provides a number of what interfaces. It provides a number of interfaces, including collection itself. You get list, map, and then set. Are you getting it? Collections are used for storing what groups of objects in Java. You get so collections API provides API just like a technology, like it's a platform. You get application programming interface. You don't know what API is, right? Just like plugins, blah blah blah, the rest. So application programming interface provides a number of application programming API provides a number of interfaces. We all know what interface is, right? It's another alternative of class, right? Interface is just like when you have when you want to inherit from more than one class, it's uh, it has to be in interface format. You can inherit two classes at the same time, except if it's you declare it as an interface. You understand? So collections are used for storing groups of objects. So the collections API provides a number of interfaces as group of classes. Are you getting it? Group of classes, and then includes collection, lists, and then um, and mapping, and then what sets, list sets, and mapping. So all these they belong to what they belong to Java. You understand? So let's get started. I hope you are getting it. Um, oh, 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 oh. So you get it. We have explained that util that package Java list classes and interfaces, explain set classes and interfaces, map classes, queues and arrays. Those are the objectives of this session. So here let's say the collection framework consists of collection interfaces, as we said earlier, which are primary means by which collections are manipulated. They also have a wrapper general purpose implementations adapter to adapt collections of order. Besides this, there are convenience implementations and legacy uh, implementations. So Java.util package contains a definition of number of useful classes providing coverage of functionality. So util Java.util package, it provides it's a package, like you all know what package is, right? I don't need to explain what package is. So Java util package, like it's just like a library that consists of different functionalities of Java. For example, if you want to use your date, time, scanning, anything in your program, you definitely have to import java.util package. Do you understand? So in java.util package, we have map, we have map, collections, date, set, and then what list. These are the what functionalities, functions that are inside java.util package. So um, the package also contains definition classes that provide date and timing facilities. Like if you want to use date and time in your project, in your software, you have to import this java.util package such as calendar, dictionary, and so on. You understand? So it also contains a list of classes and interface to manage collections of data in our memory. So a collection is a container that helps group of multiple elements into a single unit, just like grouping of objects. So collections help to store, retrieve, manipulate, and communicate data. Then the collections framework represent and manipulate collection. It includes what? Algorithm, implementations, and then interfaces. Algorithm is it includes what? Algorithms, implementations, and then what? Interfaces. Algorithm, just like the structural knowledge of your project of your program, implementations, the implementations of the program, just the software, like what it is, its usage, and then its functionalities and so on. Then interfaces, classes that are bound to come together and work as a project. So collection interface, collections program framework consists of interfaces, classes, and for working with group of objects, as we said earlier. At the top of hierarchy, collection interface is live. The collection interface helps to convert the collections type. Then the collection interface is extended by the following sub-interfaces. So these are what sub-interface of collection. We have what sub-interface of collection. We have set, we have list, and we have what queue. Set, of course, set, just like set of things. This set, another set of people, set of programs, set of files, set of anything. List, they are got in a list format. Then queue, list and queue, they are somewhat the same thing, but actually there's a slight difference. So queue is when they are arranged in how do I even put it? When they are arranged in a manner process, while list they are being arranged but not actually in a ordered format. So some of the collection classes are as follows. Collection classes, these are one in term their interface, collection of sub-interfaces, where list, queue, the set, there are collections of interface, while this one there are collections of classes. As follows, we have hash set, linked hash set, and then tree set. So method of collection interface, size, we have their methods. These are the methods. We have size is empty, used to inform about the number of elements that exist in the collection. Then contains, used to check if a given object is in the collection. Add or remove, used to add or remove elements. Iterator, used to provide iterator over the collection, which is what iteration and repetition looping, right? So traversing collections using for each constructor. This helps to traverse a collection, like to take it back, or array using a for loop, like to make it to make it budge, move forward or backward. You get, so the following course will introduce the for each constructor, and for traverse collection to take place, you definitely have to use for each. And for looping is about what repetition of process, right? Be it repetition or repetition of process, right? So traverse here is just like the example of traverse collection. Let me say, let's say the program asks you to enter your name, and you enter it, enter second name, and display result to display result. Then after, click one to start the question again. So that click one and start the question again, it's what's called traverse. You understand? Like it will repeat it again. So traverse collections, we definitely have to use for loop. So in traverse collection, not just for loop we're using, but we're using for each loop. You get, so it will print each element of a collection. That's for each game. It will print each element of a collection, and this is the code snippet for it. For then object obj collection, then system.out print the object. So using iterator, this helps to traverse through a collection. They also help to remove elements from the collection selectively. So the iterator method is called to obtain an iterator for a collection. So the iterator interface includes the following: public interface iterator, boolean harshness, email, remove, that's optional. So we have bulk operations, perform shorthand operations on an entire collection using the basic operations. So these are the these are the methods we have in bulk operation. Bulk operation is what performs shorthand operations on an entire collection using the basic operation. Contains all. This method, like from the English, you understand what they're actually saying, right? Contains all. This method will return true if the target collection contains all the elements in the that exist in the specified collection. Then add all, it will add all the collections. Remove all, it will remove all. Retain all, this will remove those elements from the target collection that do not exist in the specified collection. So list. The list interface is an extension of the list interface is an extension of the collection interface. It defines an ordered collection of data and allows duplicate objects to be added. Then its advantage is that it adds position-oriented operations, enabling programmers to work with part of the list. Okay, just like when you want to list things together and then blah blah blah. Then the list interface uses an index for ordering an element while storing them in a list format. Then list has methods that allow access to elements based on their position set of a specific element and return their position in addition to performing arbitrary range of operation. It also provides a list iterator to take advantage of its sequential nature. So here they are just talking about list. It's just about arranging your program, arranging your files, your anything you want to arrange in your software or your program, your code in a list format. So a list interface is a collection of an interface, and then it adds position-oriented operations, and it enables programmers to work with parts of the list. Like list uses index for ordering the element while storing them in a list. When you want to store them, because when you are storing them, every data you store, every object you store in a list, it has an index that refer you to whatsoever you are storing. You get. Then it also provides the list iterator to take advantage of data sequential nature. So these are the methods of list interface. We have add or get, set, remove, subplace, index of, and then last index of. Then arraylist class. Arraylist class is an implementation of a list interface in the collections framework. Arraylist, where you have a list, and then let's say you want to make the, multiple lists together, then definitely that's where arraylist comes in. The arraylist class creates a variable length array of object references. You know, when you just list a list is just like when you have a group of objects together, you listed them down. Why arraylist is just like when you have objects. When you want to have more than one list in your program, that's when array list comes in. You get. So the array list can include all elements, including null. In addition to implementing method, the list interface, this class provides method of change, and then array list can be the best suited for random access without inserting or removing element from any object. So array list, instance of array list, object of array list can be created using any one of the following. You can use any one of the following to create object of an array list, like instance of an array list. So here we have array list method, array list collection, extends array list interface, then array list variables. These are the three, right? So, and this is the following snippet for it. List string, list object, new array list initialization, right? System.out the size is this object size. Then this is where your for loop comes in. Int control 1, control reverse and equals 10 increment by 1. Then this object add value is the new integer. So this is just a snippet for array list. This is how array list looks like. So method of array list, we have add object, trim to size, you can trim it, like cut it, reduce the size, ensure capacity to ensure the minimum capacity or maximum capacity, which you have to declare the variable inside it. Then clear to clear the unwanted elements you don't want inside it, or contains of function or not contains. But if they are lists that are contained, if they are data if the list is it has data in them also, then the size of your list and then so and this is another example of array list of method. Then vector class. Vector class is similar to an array list as it also implement dynamic array. Vector class stores an array object, and then size of an array can increase or decrease. So here, array list, vector class here, it's about it's similar to array list, like group of lists, right? But here it's that it's changeable. Vector class changes, like it varies. Sometimes it reduces. When it reduces, it affects the major list, and then when it increases, it also affects the major list. So the elements in the vector can be accessed using the integer index. Each vector maintains a capacity, increment, optimal storage, and then blah blah blah. The constructor of this class is in array list it doesn't have constructor. It only has a method, and then while in the vector class it doesn't have classes. It has constructors. So these are the constructors of this class. Vector class. We have vector collections, vector int capacity, decrement, and then increment. So to create an instance of an object and vector object, just like the way you normally create your object in your normal object programs, like vector, it's just like saying class name, object name, because new class name. because vector is a class, right? So here you have vector object name, then equals to new vector. You get the same thing. You are familiar with this, right? The method of observing vector class, we have add element, capacity to array, element add, remove element, clear. So this is how the source code is, the snippet. Vector object, create the object, you get, then this object that add element, new integer 5, add element, add element, add element. So system that out of plane value is plus object element 3 element adds 3. So this is just the quick snippet of object vector. Then we have linked list. So linked list. So linked list class class implement the list interface and array stores objectives. Linked list class is just like when you have all the lists being linked together. Linked list is a list of objects having a link to the next object. And that's like when you have a linked list, like on a list where it's linked to another object. You get each such item is referred to as a node. So linked list allows insertion and removal of nodes at any insertion of the list, but do not allow random access. So Java provide linked list class in Java.util package. Linked list constructor creates an empty linked list. So this is a snippet for it. Linked list object, you create a list object equals to new linked list. And the method of this linked list we have add first, add last, add get first, get last, remove first, and remove last. Maybe it's list of letters or anything. And then these are example. Add John, add Mary, add Jack, add Elvis, add Martin, add. Then we have auto boxing and unboxing. The auto boxing and unboxing feature automate the process of using primitive value into no collection. Then note that collections have only reference, so primitive values such as have to be boxed in the appropriate wrapper class. If an int value is required to an integer, value must be unboxed using auto boxing. So the auto boxing and unboxing feature helps to reduce the clutter of it helps to reduce the clutter of code. So let's explain it. Auto boxing, let me see, how do I even explain this like auto boxing? Auto boxing, let's say it's auto boxing, it's converting a primitive value into an object of the corresponding wrapper class. Do you understand? Like auto boxing, it's convert a primitive value, into an object to the corresponding wrapper class. Just like when you have you all know what wrapper class is, right? When you convert int to integer is a wrapper class of int, right? So auto boxing is converting a primitive value into an object corresponding to the wrapper class. So wrapper class is called auto boxing. So wrapper class, another name for auto boxing is just wrapper class. Angani auto boxing, just like wrapper class. When you have int, you convert it to integer. You use integer. Int as integer. We've done wrapper class, right? So wrapper class is just auto boxing. You get? So for example, converting int to integer class. That is what auto boxing is. Converting int to integer class. Do you understand? Converting auto boxing is what? Converting int to integer class. What is integer class? Integer class is wrapper class, right? So int to integer class. So the Java compiler applies auto boxing when a primitive value is passed as a parameter to a method that expects an object of that corresponding wrapper class. And I assign a variable to the corresponding wrapper class. So auto boxing here is converting int to integer. That's what auto boxing is. So that's it. Do you understand? Why unboxing is converting an object of a wrapper type to a corresponding primitive value. It's reverse. You know what? It's reverse. Reverse is the case. Wrapper class to primitive value. That's integer to what? Int. That is what unboxing is. While auto boxing is int to integer. Do you understand? That's just it. Um, so let's continue. Uh, then set interface creates a list of unordered objects. It creates Shikuma set is on the ordered format, just like a set of things, set of class, set of varieties. So it creates non-duplicate list of object references. The set interface inherits all the methods from the collections interface. Java platform contains three general purpose set implementations. They are as follows: hash set, tree set, interfaces and extensions. When we have hash set, tree set, and then link set. We have changed set earlier. So these are the methods: contains all, add all, retain all, and then remove all. So that's it. So hash set class implement the set interface and create a collection that makes use of hash table for data storage. Hash set class allows null elements. Hash class provides contains and times performance for basic elements. So these are the hash sets, hash set collections, hash sets. Then linked list, linked hash set class creates. Of course, you all know what linked is. Is create list of elements and then maintains the order of elements added to the set. It provides all optional set operations. It permits null elements and so on and so forth. So three set class implement the navigable interface and uses a tree structure for data storage. The elements can be ordered by natural ordering or by using a comparator, provide the time of set creation, blah blah blah. The class includes the following constructors: tree set collections, extends, and then visit and maps. A map object stores data in the form of relationship between keys and values. Each key will map at least a single value. Then it also has hash map, tree map, and then link hash map. The methods we have put, get, contains key, and then size, values, and so on and so forth. So, and this is a snippet for hash map, public employee, this constructor, and variables, string to string, returns the name, and then salary, and then blah blah blah. So we can try and run this code to perfectly work perfect. Yeah, we need to import all this mapping stuff. Anyways, that won't be good. We can run it on your own. So so we have stack on queue. In a stack class, the stack object results in the last in first out, that is LIFO stack class. Then it extends the vector class, consider a vector as stack. Then it includes all the methods of the vector class. This interface includes following 5 methods: empty, pick, pop, push, and then int search. That's what interface includes in the 5 methods of LIFO, last in first out. Empty, pick, pop, and push. Pop and push is LIFO. While queue interface is a collection of holding elements that needs to be processed. In queue, the elements are normally ordered in first in, first out. Queue is in first in, first out, while list is in last in, first out. Stack, LIFO. Queue, FIFO, first in, first out. And the queue can be arranged in orders too. The LIFO queue, new elements are inserted at the end of the queue. So the queue is a double-ended queue, is commonly called the queue. When you have double queue together, like ended queue, it's called the queue. It is a linear collection that supports insertion and removal of elements. Usually, the queue implementation has no restriction of the number. The queue, when used, result in FIFO behavior. The queue is always in what? FIFO behavior. Interface implementation, which stock class provides, consisted of LIFO. Then the queue, stock new, array list, blah blah blah. Other methods of supported by the class is what: pick, call, offer, element, and then remove. Then priority queues are similar to queues, but the elements are not arranged in FIFO structure. You know, normally queues are arranged in FIFO structure, while priority queue are not arranged in FIFO structure. They are arranged in user-defined manner. The way you want it, that's how you arrange it. The elements are ordered by either natural ordering or according to a comparator. Then an element are added to priority queue, its capacity grow automatically. So priority queue classes, these are the classes we have: priority queue, int capacity, and so on and so forth. Then priority queue class as follows: add, clear, and then elements. So so anywhere you want to use hash set queue, prior queue, set queue, edit queue, you have to create an object for it. Like this, you have to instantiate it. You get priority queue like this line here. You all know, if you are familiar with this, right? Priority queue, new priority queue string, because we are dealing with string, right? So queue dot offer, New York offer, Kansas, California, blah blah blah. This here you use your classes, yeah, the methods, right? Number one, setting the order print. One, queue dot poll, it removes it. Two, poll pick removes, pick dot queue removes, and then blah blah blah. So this is how you run the stuff. An array class, we all know how array works, right? It's a provide number of methods for working with arrays, such as searching, sorting, and comparing the arrays. So the method can class thrown over exception, knowing sub-importance, then sorting collections. We have provide two interfaces for interfaces, compare, array.sort, comparator, enhancements, collections classes, and then the array_dequeue class implement the dequeue interface, and so on. So let's run this program and see. You copy it, Control C, open your NetBeans. Okay, Control A. Control V. Then copy the remaining code. Copy the remaining code. Go straight. For that, let me just arrange this. Let me make it public class the queues run something like this, then something like this again. Then I'll check this name. The name to the queues, the Java, yeah. So I guess I'll delete this. Copy. Okay, I've already copied it, right? I'll paste it. There it goes. Send it. Change. 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 So see, it has run perfectly. So public class the queue, then public our main method, then array the queue. What's the queue? What is the queue? The queue is what when you group when you group queues when you group queues together, like list of queues, when you group it and the end, when you group and ended queues together, that's where you get the queue. So here we have the queue: add last mango, add last apple, add first banana. Then these are for loop, for iterator, iterator as next. It will have the next value. Then system out dot print iter next. So here, this code here will tell us add add first. So here, when you run the code, first thing that it will start producing printing is what? Banana. As you can see, look at it here. We have banana. Then that's first. So then followed by the next iter to as next, which is apple. Add next. Then the one in the first, it will start printing this at the above. Then it will print mango. Then apple. You get. So another iteration again here again is what? In descending. This one comes in what? Descending manner. That is after at first mango apple, then in descending manner apple, mango, and banana. So that's it. Then here the first element add iq.get first. Then last element add apple.get last. Though the first element here is banana, because get first, then get last here is apple. You understand? Then contains apple, or RQ contains apple. It's true. A cikin list nan duk akwai apple, yes. If akwai apple, zai maka printing true, yes. It contains there's apple. The list contains apple in it. Okay? So that's it. Try and run it and see how it works. Enhancement collections in Java class. So the same thing. Let's see. So current skip list is the same thing here too. We have add banana, peach, apple, mango, orange, blah 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 blah. Why here? But they didn't in enhancement collections. We don't use for loop. We use while loop. So let's run it. Copy. Just yes, I have a public class. Let's say current skip list set. That's the name of my something. Name of my class. Close it. No. Close it. Close it. Then I guess I'll click this one. So I'll make changes. That's it. I believe you guys can do it. You're already familiar with it. Oh. Okay. So change rename file to current skip list set. Yeah, click on it. Then I'll go ahead and copy the remaining. C. Then I paste it. Take this one out. right there. So uh, oh. Mm, so you see this while it doesn't use a for loop. Um, Here you go. So let's run it. So if you want to print in an ascending order, apple, banana, peach, apple, banana, mango, orange, peach, in descending order. In ascending order, A, B, daga A sai B go, daga B sai M, daga M sai O, daga O sai P. See? Ascending order. While in ascending order kuma daga ƙarshe zuwa sama ko, that's peach, orange, look at it, peach, orange, mango, banana, apple, apple is the lower element is banana, higher element is also banana. So I get it here. These are the list sets, list, iterator, iterator, footer, iterator in ascending order. In descending or in ascending order, if your iterator has the next value, then it works fine. So that's in ascending order. Lower elements, fruit set, lower mango, apple. So that's it. You can try and run it. It will work perfectly fine. Oh, so at least we've done two with you guys. Then you guys will try this one and run it. That's it. So perfect. This Java summary util. That's end of Java 3 session 3. So these are the summary. You read the summary and then so we'll meet next time again.